A research and policy-based discussion upon the cross-curricular ideas of maths and science. This presentation will begin by looking at what is meant by cross-curricular and discrete teaching. It will move on to look at the historical debate leading up to the current arguments of today. The presentation will address pedagogical and organisational issues. It will link the debate specifically to science and maths, including examples. It will then look at the use of ICT as a help or hindrance to cross-curricular teaching. Finally, the presentation will conclude that there is a unique link between maths and science, and that cross-curricular teaching, though undeniably beneficial, may not always be the most practical method throughout all of the school day. The concept of cross-curricular teaching is not new. In 1989, Jacobs defined it as a conscious effort to apply knowledge, principles, and values to more than one academic discipline simultaneously. This may be related through a central theme, problem, or process. In contrast to this, discrete teaching focuses on one subject at one time. The cross-curricular debate has always occurred, beginning with the Haddo report in 1931. In his review, he argues that the topic approach is preferable to dividing the curriculum into separate subjects. This, he argues, is because the curriculum should be based on experience rather than abstract principles. Over 30 years later, this point of view was strengthened by Plowden, who crucially states that children's learning does not fit into subject categories. In addition, he argues that work and play are complementary and should not be separate. Despite these arguments, the Education Act of 1988, following the 1987 National Curriculum, believed the best approach was to divide the curriculum into discrete subjects. This would have made cross-curricular work very difficult to implement effectively as a teacher. An important development in terms of the cross-curricular debate was the publishing of the Three Wise Men report. The report argues that children must be able to construct their own meanings and that it is the wholeness of the curriculum that is important rather than the discrete identity of individual subjects. More importantly, the report discusses the importance of organisational issues in that pupils must be able to grasp the principles and procedures of each subject and progress in their knowledge or understanding. This can be interpreted as meaning the cross-curricular or discrete approach must be used with the benefit of the child's progress in the subject as the main reasoning, as it goes on to criticise poorly planned topic work that results in low and superficial understanding as being the cross-curricular downfall. The review by Jim Rose in 2009 found that all of the effective primary schools that were visited carefully planned and managed its curriculum to provide children with both systematic specialist subject teaching and rich cross-curricular studies. This outcome was echoed by Ofsted in their 2010 report. They went on to find that cross-curricular projects contribute to develop a broad range of skills required for later success, for example, being able to problem solve. The next part of this presentation will address the advantages and disadvantages to cross-curricular learning with reference to maths and science. Cross-curricular teaching in primary schools helps the teacher plan a more imaginative, integrated curriculum. This can then be used as a more accessible way for children to develop the required skills across a range of subjects. Harlem and Qualter, 2009, argue that the cross-curricular teaching allows subjects to be more meaningful and engaging. This then enables children to access a deeper understanding and to present their skills in other areas. Barnes, 2012, adds validity to this argument by stating that cross-curricular experiences encourage exploration of topics and creates further questioning by engaging students. This is undeniably a key skill required in both mathematics and science. In contrast to this, Kerry argues that knowledge falls naturally into domains or subjects which are bounded by specific or conceptual thinking, and using procedures that are specific to the subject. This interpretation is key to the central argument of this presentation. As though this may be true for some subjects and therefore they may not benefit from being taught in a cross-curricular way, it does not fit the subject of science and maths. As Rosemary Feasey states, at the heart of science is mathematics. Science relies on quantitative data, comparisons, patterns to draw conclusions, all of which can be accessed from the use and understanding of mathematics. It therefore stands to reason that maths and science are not bound by separate conceptual thinking and procedures. Rather, the same thinking and understanding is required for both. Therefore, surely the teaching of maths and science in a cross-curricular way would prove more beneficial to a child's overall understanding. One of the biggest criticisms of cross-curricular teaching is in the teacher's own subject knowledge. This highlights the issues of pedagogical and organisational tensions. As several academics note, cross-curricular methods underpin much of primary school pedagogy. A prime example comes from Rowley and Cooper, 2009, who argue that it is a clear issue in the teacher's planning and their ability to find a balance between their own perceptions on how subjects link in the most effective ways. This, it may be argued, is particularly crucial in the understanding and teaching of mathematics. As Skemp argues, relational understanding is crucial to ensure not only a child's interest but their mathematical ability in later life. As there are clear links to enhancing mathematics with the use of science, if a teacher's own subject knowledge is not good enough, it is likely that the teaching will be of instrumental value, thus neither beneficial to a child's skill or enjoyment in either subject. Furthermore, Alexander enhances this point of view by stating that a teacher with poor subject knowledge using cross-curricular methods is counterproductive. A further argument in favour of discrete teaching comes from Barnes, 2011. He comments that cross-curricular teaching results in less clarity about what the subject entails. This then creates doubt as to how to assess a student's understanding of a subject. This is undeniably a central issue within the debate, as one of the most important roles a teacher plays is the ability to move a child forward with their understanding. We may therefore question if it is worth the risk of not being able to achieve this over the idea of creating a more engaging lesson. Chris and Rowley argue that it is therefore essential for a school to have a whole understanding on their own policies to enable long-term assessment on all learning, whether it is from discrete or cross-curricular methods. According to Hayes, 2010, cross-curricular links between some subjects are more natural than they are between others. This is particularly true for science and maths. The new national curriculum states that mathematics should be linked throughout all subjects. In addition to this, one of the key aspects is problem solving, an area that goes hand in hand with science. Each Friday morning at my placement school, there is a problem solving session. This provides the opportunity to enhance children's understanding of what has been learnt during the week through the completion of a science investigation using mathematics. The National Centre for Excellence in Teaching in Mathematics provides an in-depth section entitled "Where's the Maths in That?". This gives inspiring ideas from across all key stages to enhance both maths and science teaching with the use of each other. The concept can be applied to many areas of the maths and science curriculum. For example, in the grouping and classification of living and non-living things, or in the use of Carroll diagrams to present data on different rock types. In particular, I will be looking at the use of measurement, as I believe it is the most beneficial link between the two subjects. In this lesson, the children had to firstly use reasoning to predict who would have the longest and shortest body parts within their group. They then had to estimate what these lengths would be, using the correct units, and finally decide which equipment would be best suited to measuring and why. Prior to this lesson, the children completed measurement work only in maths lessons. The application of measurements, choosing the correct units and equipment to a real and visual situation through science, provided a greater depth of understanding for all children in the class. In the growing digital age, the use of ICT within the classroom is becoming more important. According to the Primary Interim Report, ICT has the capacity to enhance all subjects to deepen understanding. This may be particularly true for maths and science, for example with the help of data loggers. Technology can be used to accurately record and store information to enable more attention to be given to reasoning and interpretation. In addition to this, ICT is invaluable in creating graphs in a variety of formats, enhancing the data and statistical elements of both maths and science. This, it may be added, however, would not be useful for Key Stage 1 children. In addition, as Sherman, 2004, argues, ICT provides methods of learning for children with special education needs that they may not access without. The downside to the use of ICT, however, is that it will only enhance the teaching of maths and science if used by a teacher who understands how to utilise the full potential. As much of the cross-curricular debate shows, it is down to the teacher's own understanding to use their available resources to their maximum potential. In conclusion, it is clear that the cross-curricular debate is one that has been explored by many academics and taken in many directions with no definitive answer. The 2008 independent review of the primary curriculum concluded with the recommendation that neither discrete subject teaching nor cross-curricular studies must disappear from primary schools. Rather, schools should protect times when discrete teaching is most effective, while providing many opportunities to use skills and understanding developed from cross-curricular learning. Furthermore, this presentation has shown that there is a definite special link between maths and science that can be used to enhance the teaching of each subject. However, it is crucial for the teacher to understand the links to ensure the greatest understanding and potential from the students.